Have you ever wondered how weather affects aviation? It's a question that many ponder, and the answer is more complex than you might think. Weather, in its myriad forms, plays a key role in flight safety and efficiency. It's not just about whether it's raining or sunny on the day of your flight. The impact of weather on aviation extends far beyond the airport tarmac. In this exploration of aviation weather theory, we'll delve into the importance of atmospheric pressure, the role temperature plays in air density, and how wind and currents can influence flight time and fuel consumption. We'll also look at the effect of moisture in the air, from the formation of clouds and fog to the potential for icing conditions. Beyond that, we'll discuss visibility, and how reduced visibility due to weather conditions like fog, rain, or snow can shift a pilot's reliance to instruments for navigation. And let's not forget turbulence, a phenomenon caused by factors such as wind shear, storms, and mountain waves, which can pose a risk to flight safety. Join us as we delve into the fascinating world of aviation weather theory. First, let's take a look at atmospheric pressure. This invisible force exerted by the weight of the air above us is something we don't often think about in our daily lives. But in the world of aviation, it's a game changer. Why is it so important, you might wonder? Well, changes in atmospheric pressure have a significant impact on aircraft performance, especially during the critical phases of takeoff and landing. Imagine atmospheric pressure like an invisible sea of air through which an aircraft must navigate. As a plane ascends, the atmospheric pressure decreases. This reduction in pressure means the air becomes less dense, and there's less air for the aircraft's wings to push against, making it harder for the plane to generate lift. On the flip side, during descent, the aircraft encounters increasing atmospheric pressure. The air becomes denser, providing more resistance, which can affect the aircraft's speed and cause it to consume more fuel. Also, atmospheric pressure variations can affect the performance of an aircraft's engine. Higher atmospheric pressure means denser air, which allows the engine to take in more oxygen and produce more power. Conversely, lower pressure results in less dense air, reducing the engine's performance. The aircraft's altimeter, which measures altitude, is also affected by changes in atmospheric pressure. Pilots must regularly adjust the altimeter to account for these changes and ensure accurate readings. So, as you can see, atmospheric pressure plays a critical role in safe and efficient flight operations. Next up, we have temperature. Let's dive into the fascinating world of thermal physics as it relates to aviation. You see, temperature plays a vital role in aviation, and it's more than just about comfort in the cockpit. It's about how the air behaves, and more importantly, how your aircraft responds to it. Picture this. You're cruising on a hot summer's day. The air is warm and it feels less dense. Now, if you remember your basic physics, you'll know that warmer air is indeed less dense than cooler air. But what does this mean for your flight? Well, in the world of aviation, air density is a big deal. It directly influences the amount of lift that an aircraft's wings can generate. When the air is less dense, the wings produce less lift. This means on hot days, your aircraft might need a longer runway to take off, or it might climb more slowly after leaving the ground. But wait, there's more. Engine performance is also affected by temperature. Aircraft engines, whether they're piston or jet, rely on air for combustion. The less dense the air, the less oxygen is available for combustion, and this can reduce engine power output. So again, on a hot day, your engine might not be as peppy as it would be on a cooler day. That's why pilots need to be aware of temperature variations and their potential effects on their aircraft. Because in the sky, understanding the effects of temperature isn't just about knowing if you'll need a jacket. It's about ensuring a safe and efficient flight. Now let's discuss wind and currents. These two factors play a significant role in aviation, influencing both the efficiency and safety of a flight. Wind direction and speed are not stagnant. They can change dramatically and unexpectedly, so understanding these variables is crucial for effective flight planning. Imagine you're piloting an airplane. The speed and direction of the wind can significantly impact your fuel consumption and flight time. If you're flying with a strong tailwind, it can push your aircraft forward, reducing the amount of fuel you need to maintain your speed, and thus shortening your flight time. On the other hand, if you're flying against a strong headwind, your aircraft will need to work harder to maintain its speed, consuming more fuel and lengthening your flight time. Now let's talk about currents. Air currents, like wind, can also affect an aircraft's performance. Updrafts and downdrafts, for example, can cause an airplane to climb or descend unexpectedly. These unexpected changes can be challenging to manage, especially during critical stages of flight like takeoff and landing. Incorporating wind and current data into flight planning helps pilots anticipate these challenges. They can adjust their flight paths, altitudes, and speeds to account for these atmospheric conditions, ensuring a safer and more efficient journey. Understanding wind and currents is therefore vital for efficient flight planning and operation. Moisture is another important factor in aviation weather. It might seem insignificant, but water in the air can dramatically alter flight conditions. When the air is moist, it can lead to the formation of clouds, fog, and precipitation. Each of these phenomena can greatly impact visibility, making it harder for pilots to see and navigate. Clouds, for instance, are not just fluffy white forms we admire from the ground. They can be a real obstacle in the sky, obscuring a pilot's view and making navigation more challenging. The types of clouds can also indicate certain weather conditions, with some signaling a potential for severe turbulence. Fog, too, is a product of moisture and can severely limit visibility. It's like trying to navigate through a gray wall, where even the runway can become hard to discern. Pilots are trained to handle such situations, but it's always preferable to have clear skies. Precipitation, whether it's rain, sleet, or snow, is another factor to consider. It can affect visibility and the aircraft's performance. Heavy rain can make runways slippery, while snow and ice can build up on the aircraft, affecting its weight and aerodynamics. But perhaps the most dangerous aspect of moisture is the potential for icing conditions. When supercooled water droplets in the air freeze upon contact with the aircraft, it can lead to ice accumulation. This can alter the shape of the wings and tail, affecting lift and control. It's a serious situation that pilots are trained to handle, but it's always best to avoid when possible. So, moisture is more than just a minor inconvenience. It can seriously impact flight safety and efficiency. Let's talk about visibility. In the world of aviation, visibility is not just about what we can see, but how we can interpret the unseen. Weather conditions such as fog, rain, or snow can significantly reduce visibility, turning the familiar into the unknown and making navigation a challenging task. Under such circumstances, pilots have to rely more extensively on their instruments. The instruments, acting as the eyes of the aircraft, provide crucial information that helps navigate through the weather-obscured skies. From altimeters to airspeed indicators, from heading indicators to attitude indicators, each instrument contributes to the overall situational awareness of a pilot. Furthermore, technologies such as weather radar and satellite imagery can provide real-time information about weather conditions, helping pilots anticipate changes that could affect visibility. But it's not just about the technology. A pilot's ability to interpret and make decisions based on the information provided by these instruments is equally important. This requires not only technical knowledge, but also a deep understanding of weather patterns and their potential effects on visibility. In essence, good visibility is not merely about clear skies. It's about the synthesis of technology, knowledge, and decision-making skills that allow pilots to safely navigate through all kinds of weather conditions. As you can see, maintaining good visibility is crucial for the safe operation of an aircraft. Finally, we have turbulence. Now, turbulence is a term many of us have heard, often in the context of a bumpy flight. But what exactly is it? Turbulence is a form of atmospheric instability. It's caused by various factors, each with its unique characteristics. Firstly, we have wind shear. This is a sudden change in wind direction or speed over a short distance. Picture a calm river with a swift current underneath. That's wind shear. It can occur both horizontally and vertically in the atmosphere, and it can cause sudden jolts in an aircraft. Next, we have storms. These powerful weather phenomena can create turbulent conditions due to the rapid upward movement of air, causing an aircraft to experience sudden and unexpected movements. Lastly, there are mountain waves. When a steady wind blows over a mountain range, it can create waves in the air similar to waves in a body of water. These waves can extend high into the atmosphere, and if an aircraft flies through them, it can experience turbulence. All these factors pose a risk to flight safety. Turbulence can cause discomfort for passengers, but more seriously, it can lead to loss of control for pilots if not properly managed. That's why understanding turbulence and its causes is so important. It allows pilots to anticipate potential turbulence and adjust their flight path accordingly to ensure a smoother and safer journey. Turbulence is a major concern in aviation, and understanding its causes can help pilots better navigate through it. We've covered a lot of ground today, from the role of atmospheric pressure and its impact on aircraft performance, to the influence of temperature on air density, lift, and engine performance. We've discussed how wind direction and speed are critical for flight planning, affecting fuel consumption and flight time. We've looked at how moisture in the air can lead to cloud formation, fog, and precipitation, which can impact visibility and potentially create icing conditions. We've also delved into the importance of visibility and how reduced visibility due to weather conditions requires pilots to rely more heavily on their instruments for navigation. Finally, we've explored turbulence, caused by factors such as wind shear, storms, and mountain waves, and how it can pose a risk to flight safety. Understanding these weather elements and how they interact is essential for pilots to make informed decisions and ensure a safe flight. Thanks for joining us on this journey through aviation weather theory.